Hello, I'm Jake Schmulz, and this is the reaction between sodium chloride and silver nitrate. This reaction is important because it's crucial for forensic science. All you guys know that we have fingerprints. All of us have different ones. And if we leave a fingerprint on a smooth surface, it'll leave organic compounds such as amino acids, oils, and most important, water. Over time, water evaporates and releases a salt, so sodium chloride. And sodium, that's huge because sodium chloride will react with silver nitrate. And how they do that is you just basically, they have this sodium chloride, they'll lift the fingerprint up using like a clear tape. I think most of you guys have seen that from like a flat surface, and they'll use sodium chloride, or they'll use silver nitrate to just basically reveal the latent fingerprint. So it'll be more visual, and they'll find the loopholes from it, and the more loopholes they have will have more evidence to connect it, so still better. So what's the point of this? You identify the polyatomic ions, the spectator ions, through a double displacement reaction, and create an understanding of the scientific method. So how you do this experiment is you basically just take 50 milliliters of 1.0 molar solution of NaCl, and then you have to basically mass out the NaCl, and you have to calculate that mass, and I'll show you through a calculation. And then you'll add it to a volumetric flask, and you have to stir it up pretty well in distilled water, and then you'll add 1.0 molar, or 1 milliliter of silver nitrate, and you will have a reaction. The reactants. So NaCl looks like normal table salt. And then silver nitrate, it's kind of clear. It can come in different forms too, but silver nitrate you have to be careful about, because if you get it on your skin, it will severely burn you, so be careful with that. This is the visual of the experimental. So here you have basically sodium chloride being mixed in the water here, and you have to shake it up pretty well. We had a volumetric flask, and we just did inversions with it, and then we reacted the sodium nitrate, so that clear substance up at top, and then we got a white solid. So here's my results. So we initially had 2 clear and colorless solutions, and then a white solid formed. And this is the one calculation I had to do. I took 50 milliliters of NaCl, and I divided by 1,000, and then that gave me my grams. And then I basically 2.0 grams, and I added it to a scale and stirred it up. And results continued. So earlier I said, how do I locate the spectator ions? Well, the reaction performs a solid, so silver chloride, and then the 2 spectator ions would be sodium and nitrate. So this here you have an overall balanced equation. You have a complete ionic equation and net ionic equation. This is using the double displacement reactions. And conclusion, silver chloride is our product. It's a white solid. And this is huge for forensic science, because if you have a fingerprint, that's sustainable evidence that you were at the crime. So each fingerprint has a certain number of loopholes, and the better the reaction, the more loopholes you can find in that fingerprint. And then these are my references.